Well, welcome back, everyone. We're about ready to start week 7, and pretty much for what we're doing week 7, it's getting through chapter 4. This is going to be the extent of what we're covering. Unit 4A, we are mostly through. We're on the last example. This one was kind of wide open with a lot of different topics, but the main takeaway is going to be the work you're doing on the quiz 5 on building a budget, looking into the inflow minus outflow to see the net cash flow on a monthly basis. There's lots of unit conversions and things that go along in these notes here. Then units 4B and 4D get pretty specific. So we're going from pretty general open topics here to highly specific topics, both in 4B, compound ending, compound interest, and then looking into loan payments, credit card payments, and mortgage payments in Unit 4D. But before we get started today, any questions or comments to start us out? Okay, well, also you'll notice down below, we're getting pretty close to the halfway mark, midterms week. So this is what we have going on in kind of the far future in the schedule. On the 2nd, we're going to be getting through midterms week. Then, let's see here. On the 9th will be a week as normal, and midterms week is a normal week as well. All that happens for our midterms in this class is on the 6th, once I'm done grading the course, pulling the grades from the MyLab homework system, I'll just report what your total course score is on the 6th as your midterm grade. Then the other thing that's going to come up is we have spring break on the 23rd. We'll be doing our second exam on Monday, the 16th. It'll be open from Monday through Thursday, just like the other exam, but we'll have our second exam on this week here. We'll get it out of the way before going on to spring break. So that means on Friday of this week, Friday the 13th, it looks like, that's when I'm going to be putting together the information for the second exam, the exact coverage, the review problems, and that kind of material. So that's what we have going on so far in the future. Any questions at the moment? Okay. Also, one thing I want to mention about these sections, we're going to finish off Unit 4A. We'll be using the Desmos calculator as usual. It's a pretty fast classroom demonstration calculator to use. But these next two sections get pretty intense. They're really going to be our first sections where we're using a big formula, using the calculator in a very important and direct way. So it's a good idea to have the scientific calculator you're intending to bring to the exam room with you today, the same calculator you'd be using to practice the MyLab homework. I'll be using this calculator here because it's cheap, gets the job done, and you can put your information all in one line and also edit things if we make mistakes, go back to prior computations. So let's get started. We'll finish off our Unit 4A, the last question on insurance, and then look into issues on compound interest. So here's where we left off. We're talking about insurance costs for the last, I think there's like 4 or 5 good topics in these notes. It's pretty general. But the last topic was insurance costs. We looked into this in the context of auto insurance, where copayment definitely didn't come up. Now we're looking into medical insurance, where we're comparing 2 plans. Plan A, which is a low deductible, Plan B, which is a high deductible, in the context of a certain medical situation that happened for this individual. Just to review, when they say the premium, they're talking about the amount that you have to pay just to purchase the policy. And so this Plan A says it's a low deductible policy, but there's a balance to that. It's low deductible, yet it's a high premium policy. Plan A, you have to pay $6,000 every year to have that policy. Whereas Plan B, it's high deductible. So the deductible changes by a lot from $300 in Plan A to $2,500 in Plan B, but the premium is a little bit more manageable at $1,800. So that's the premium, the amount we have to pay out of pocket. A lot of times for health insurance plans, these are possibly just a monthly payment that you'd have to make. But we're looking into this all as a yearly cost. After that is the deductible. Much like with car insurance, this is the amount that you're personally responsible whenever an insurance event happens. Doctor visit, emergency room visit, maybe a lab appointment, something along those lines. For the low deductible policy, there's a deductible of $300 for the year, which is quite nice. So anything that goes beyond that initial $300 cost, which we're on the hook for, it'll be completely covered after that point. Insurance is making up the cost on the high premium. For the Plan B, the high deductible one, we are responsible 100% for everything up to $2,500. Then it starts covering the cost, but not at 100% like Plan A does. This one's kind of a nice policy. So that's a breakdown so far in the two plans. Co-payments are another unfortunate reality with healthcare. It looks like with Plan A, there are no co-payments whatsoever. So this is the money that you have to pay out of pocket, sometimes right at the time of service before the doctor even sees you, depending on the office, for each health event that occurs, whether it's a routine checkup, getting a lab done, emergency visit, and so on. It says, for example, if you have $50 co-payments for office visits, then every time you visit your doctor, or maybe it's a dentist that this applies to, you have to pay $50 out of pocket. Kind of rough. But Plan A, again, it's kind of nice. After we get through the $6,000, probably again on a monthly payment, there's no co-payments whatsoever on this plan. Plan B is different though. It says for this plan, co-payments just depend on the events that occurred. For an emergency room visit, it's $100 co-payment. That already kind of hurts. $100 for radiology appointments, such as CT scans, it says, and $25 for an office visit. That sounds about right. I think for my insurance, it's either $20 or $25 for each visit. And Plan B gets a little bit worse. It also says the insurance covers 80% of all expenses after the deductible is met and your co-payments are subtracted. Which means after taking out the deductible and co-payments, we are on the hook for 20% of the medical bill. And 20% of the medical bill, you can imagine, could be an astronomical amount if it was something really big, like say a heart attack or something along those lines. But so far, this is the breakdown of premiums, deductibles, and co-payments. Any questions at the moment, looking at these definitions or how it relates to the plans? Okay, it says for this problem, find the out-of-pocket expenses under each plan. Maybe we're thinking along the lines of this person is trying to shop around for the right health insurance plan and is looking at what a typical event might look like or a typical year for this person. So find out-of-pocket expenses for each plan, assuming that in 1 year, you have one emergency room visit that costed a lot, $5,400, annual checkup at $185, and a CT scan that costed $700. Round to the near cent. Well, let's begin with Plan A, looking into these. In Plan A is nice, other than we have an annual premium of $6,000. We can say for Plan A, the yearly cost is going to be, first, we'll definitely pay the premium, $6,000. After that, no co-payments whatsoever. So no matter how many visits we're looking into, co-payments don't apply to this plan. There was some pretty big costs that came up, the $5,400, $185, and $700. But the deductible on this was very, very low at just $300. So even though the first event is in the thousands, all we're going to pay for the total medical expenses is just the $300. So go plus 300, And this plan is going to cost us $6,300 altogether. So more likely for a real plan like this, again, the $6,000 is split over the 12 months, but you might have had to pay that bill in its entirety potentially in a single month. Well, any questions at all, folks? Looking into the Plan A side? Okay, so Plan A is nice that it's kind of fast to compute. And Plan B is where things get kind of complicated. And we also have to think realistically, health insurance might not be calculated the way we're about to calculate it. It's a pretty messy industry. There's an entire additional industry in medical billing, medical coding, that kind of stuff to determine exactly what the cost of any one bill is going to be. So we're doing this problem again, pretty similar to how you would do this problem as just a simple MATLAB type of problem. We're focusing mainly on the definitions of the premiums, deductibles, and copayments. And they say that for this plan, insurance is going to cover all expenses. They're referring to these three expenses right here. After the deductible is met and after copayments are subtracted. So again, that might not be completely in line with reality for if this was three real bills we had. But this gets us started thinking about the comparison between the two plans at least. Let's start off by organizing since there's lots of things happening with Plan B. Let's maybe begin by just saying the total medical bill, putting these three costs together into one. The total bill, this is not what you have to pay. This would be something you might see on a so-called EOB statement, an explanation of benefits. Total bill is going to be the $5,400 emergency room visit plus the $185 regular checkup, and those are expensive, $700 CT scan. So I'm going to treat myself to the calculator on this one. 5,400 plus 185 plus 700 gives us a total bill of 6,285. Now we're told that insurance covers 80%, but we can't work with that percentage yet because they're going to cover 80% of expenses after the deductible is met and also after copayments are subtracted. So we have to bring in the deductible on this plan as well as the copayments. That's the wrong color. It's going for yellow on that. We already know the deductible is $2,500, so that's money we have to pay out of pocket after these medical expenses accrued up to that figure. But copayments, they were already paid. They were paid probably on the emergency room visit, the annual checkup, and the CT scan. So let's subtract that maybe to start. Or maybe let's just add up all those copayments. Let's say total copayments. Let's see, there was double checking the plan. There's lots going on here. There's an emergency room visit, and it costs $100 for each visit. So thankfully there's just one. So take $100 there. Next, there's an annual checkup, and let's see, all the way over here, it says $25 for an office visit. That seems to fit with the annual checkup. So add $25 there. One CT scan, the bill's $700, but probably what you paid before they even put you in that machine was the $100 copay for the radiology procedure. So add $100 to that. So out of this total bill, we've already paid this total, $225. So copayments are now aggregated there. We are going to subtract off those copayments. We also have a deductible. Let's just state it down on paper down here to organize. Deductible. Looks like it was immediately met after that first incident in the emergency room. So the bill is going to be $2,500 for the deductible side. So these are two expenses we're definitely paying, and then a little bit more, because we also have to pay the premium. Let's put that down on paper to not forget it. Again, this one might be on a monthly basis, but we're thinking yearly cost altogether. So we have a $1,800 premium. And also on this total medical bill of $6,285, insurance covers 80% after doing some subtractions. So let's make that our next step. Find out what this bill reduces to after taking out the co-payments and the deductibles. Lots of hoops we're jumping through already. This is one of those problems where it's good to kind of go slowly, organize the information before jumping into the next thing. Does that look all right to everyone so far? Okay. Let's take the total bill minus the deductible and co-payments. That's going to be the $6,285 minus, we've already chipped away at it at $2,500 minus the co-payments, $225. So this total medical bill for those three events now comes down to, let's take a look, 6,285 minus 2,500 minus $225. It's now at $3,560. Still a humongous chunk of change that would break the bank for, I think, just the average person. $3,560. But remember, we have insurance, so the insurance is going to cover 80% of that total bill. Let me just double check my number one more time. Okay. Well, them covering 80% means we pay 20%. So even though 80% coverage seems kind of nice, 20% of that is actually a lot of money. 10% would have been well over $350, $356. We're doing 20% of that. So let's give this a good title. We have the total bill minus deductible and co-payments. So we can say out of pocket expense is going to now be, we're owing 20% of this. So we take that number, write it in decimal form as 0.20. 20% of that out-of-pocket expense means multiply it by this, the remainder after co-payments and deductible, 3,560. And we get 3,560 times 0.20, $720. Excuse me, $712. Said that kind of funny. It's a pretty big amount. And again, you can imagine if the emergency room visit was more substantial, if you had to stay for a few days or heaven forbid, a couple of weeks, that bill is going to be potentially tens of thousands of dollars. And this is going to be a huge amount of money. Medical debt is, last time I looked into this, one of the number one reasons that people go bankrupt. So this plan, only covering 80% of all expenses, actually could leave us really, really exposed. It has a low premium, but there are some big risks and trade-offs going along with it. And we still don't know the total yearly costs, but we have figures we can now finally add all together. That's the out-of-pocket expense. Let's start there and say total yearly cost. Let me put some of these answers in a box just because it's starting to look like a cloud of math going everywhere. For plan A, that was the total yearly cost, $6,300. For plan B, we're finally getting a total yearly cost of Out-of-pocket expense, $712. Then what came next? You had to pay the deductible because our first bill was already beyond the deductible, but we stopped right at the 2,500 at least. We just had to pay that extra 20%. So 2,500 here. Then we still have to pay the premium. So we go over to here, $1,800. And don't let me forget any part of the bill. It's easy to do with all these pieces. $1,800 here. That's not all we paid. There's one last thing that I almost missed. Anyone see what the last part of the yearly cost is?
The copay.
Yeah, good call. That copay, it looks kind of small, but it is a big deal. $225. 225. Putting those all together, we'll see how we compare with Plan A. So $712 plus 2,500 plus $1,800 is a yearly guaranteed cost on this, plus the copay gets us to $5,237. I'll put that in box to convey that finally answers this original question. Find the out-of-pocket expenses under each plan with the assumptions of the medical events that happened for this individual. So plan A actually looks kind of worse, right? It costs more. Plan B came out to less. But this is in one specific situation, and it's easy to imagine that if one of these bills, say the emergency room visit, was, say, much worse, order of magnitude, say 10 power 4 or 10 power 5, then this starts to become a nightmarish kind of picture. But for a person who can't necessarily take a huge premium, they feel reasonably healthy and they're willing to take on some risk, Plan B might make some good sense because it did come out substantially less. Well, that's the end of the entire notes here. The last question we're going to look at with insurance. There's a pretty similar one as well on MyLab, just different kind of scenarios and different values stated for deductibles on the plans and so on. But any last questions at all, folks, getting through this one? Okay, I would say one of the other kind of fringe benefits of doing this kind of problem is just familiarizing ourselves with the language of premium, deductible, and copayment, how it relates for these kind of situations. Even though it's kind of simplified and medical billing gets a lot more complicated, if you can do this kind of calculation, you can try to take your medical bill, see if you can make it to make sense. And if you can't, then sometimes there is errors in medical billing as well. That would be something that could potentially help you out, save you a lot of money. But let's save this up. And we completed the unit 4A. Again, it's lots of topics in this particular unit. I'm not going to try to ask every single problem on a real exam question. So when we are coming closer to exam 2 and I put down the review problems, I'll show you which problems from this unit make the most sense in an exam setting. The budgeting one with monthly cash flow is my thought for being one of the more typical kind of exam questions. Well, any last questions or comments whatsoever, folks, before we turn to the next unit? Okay, let me get that loaded in. And so far, we've been using the Desmos calculator pretty much the whole course, but this is the moment at which a good scientific calculator is going to be required for exams. And it's a good idea to have it ready to go when you're doing the MyLab homework, doing your quizzes as well, during the lectures, just so that you get extra practice with the same calculator you intend to bring to an exam. And let me see if I can get these windows to make some better sense. I'm going to put this here so we can practice the calculator as we do these notes. First couple problems do not use it in a big way, but still we want to practice as we go. And we'll eventually use this quite a lot. So let's place this here. Let me see if I can get that to fit. Okay, I'm not good enough with the Windows resize tool, I thought, as I thought I was. I'll just sort of place it. Okay, that'll do the job. So to start out, we're going to look into issues with simple interest. Then we'll get into other issues with compound interest. Our formulas are not going to be too bad in the first two examples. After we get through a comparison example 3, this is where the formulas start to get a little bit more troublesome. They get involved lots of different moving parts. And we have a power here, so we'll be using the exponent key on our calculator quite a lot as well. So we'll be practicing these formulas quite a bit. They get more and more involved as we go, but once we get to this formula, practicing the earlier examples, it won't be as bad. It's more about just building up to this one. And then the next unit, on 4D, the formulas, sure they look worse, but we're building on our way towards those. Once we get through Unit 4B, the problems here in the formulas will make a lot of sense. So we'll be spending a lot of time showing how the calculator works, how to input results, get accurate answers out, and how to work through the formulas on a step-by-step basis. But before we get to the big compound interest formula, we'll begin with simple interest. Simple interest is one of those things where there's essentially no bank in the land that offers simple interest, but it's a good starting point, and there are arrangements amongst friends and family where simple interest is sometimes applied. Just like the deductible, premium, medical terminology, or insurance terminology, we have a new set of terminology when we're thinking about dealing with compounding. First thing that we are interested in is the principal amount. This is thought of as a starting amount or a present value of an account on which interest is going to be paid, whether it's money that you're investing or money that maybe you borrowed from someone and you're going to have to pay back. We think of that as the principal. And the idea of simple interest is that it is interest paid only on the original investment, so only on the principal amount, and not on any interest added at any later date whatsoever. So again, it's kind of a nice arrangement between friends, but a bank like Wells Fargo will never offer this plan, nor will any credit union whatsoever. They're going to do compound interest, and that's going to be the major goal of these notes, to see how the formulas adapt in this new landscape. So the difference between simple interest and compound interest is that compound interest is paid both on the original investment and on all interest that's been added to that original investment. So we pay interest, or we earn interest on interest, or potentially are paying interest on interest when we're looking into compound interest. So that's the initial definitions. And like the other notes, the first couple of examples are kind of warm-up problems, but there's problems just like these in the MyLab exercises. Any questions at all, folks, with the terminology before we start off example 1? Okay, well, in this example, really it's all about just getting used to the new terminology. It says you deposit $300 into an account with an annual interest rate of 4% that pays simple interest, and we want to know how much will you have in the account after 5 years. First thing we want to identify is the principal, and we often denote it by uppercase letter P in the formulas we'll be using. Here, when it said you deposited $300 into an account, that was the principal amount. So a good strategy on any one of these exercises really is to just read through the context and then start separating things out that you notice fit a variable that's part of a formula. Because recall, our end goal is to get to this formula, and there's lots of stuff that didn't quite format right. Let me see if I can fix that. There we go. There's 5 different variables here. So if you can pick that out of the context, it makes all the problems a lot easier, because then you're just plugging things in to work through the formula. So write down on paper, and this helps with the subconscious as well. Your brain is going to chew on this thing and know where to plug things in. The principal on this is $300. And definitely use the symbol that we're going to be using for the formulas. It's going into an account with an annual interest rate of 4%. But when we talk about interest, the way we're going to indicate this in the formulas is going to be written as APR. We'll define that as well. APR means annual percentage rate. So that's another big thing that we use in our formulas. So if they tell us the APR is at 4%, what we would want to write down on paper is APR equals, now we have to be careful here because one big assumption in every single formula we state is that the interest rate or the APR is always in decimal form. So if you see a 4%, write it as 0.04. All we've done is taken 4%. Oh, that's too many zeros there. If it's as a percentage, it really just literally means per 100. So you could at any point take the percentage per 100, looks like this on the calculator, and you get that result. Or if you like the decimal shifting idea, what we did is we had a decimal point here where the red dot is, but that's as a percentage. As a decimal, we always move to the left 2 spots. So we'll state our APR as that decimal number. We also have a term of 5 years altogether, and we're usually going to use the variable y for the term of the loan or the term of the investment. So 5 years on this one. Well, that's the organization of the problem. The computations aren't too bad just yet, so we're not going to use this calculator so far in a very big way. But any questions at all, folks? Just breaking down the context. Okay, the problem is asking us how much is going to be in this account, assuming we're not making any withdrawals, we're not making any further deposits. How much will we expect to have in 5 years, but earning simple interest? First thing we can look into is just what is the interest in 1 year and multiply it by 5. So we can say interest in 1 year is going to be take the principal amount, P, multiply it by the APR, and we get $300. Actually, I don't like the way I wrote that down. Let me just make that look a little bit easier to the eyes. Take P times the APR. Parentheses are a great way to say we're multiplying in the formulas we're about to use. So this will be equal to $300. Multiply it by 0.04. I'll continue to use the Desmos calculators until we're getting into those bigger formulas. We'll get 300 times 0.04, $12 in 1 year. So nothing major, but we managed to save aside $300, and now we have, in 1 year, $12 earned. So the total balance would be $312. Now, if this was a compound interest problem, we'd be earning interest on the next year on $312. So it makes it slightly more money than what we're about to look into. Here, if it's simple interest, and after 5 years, we can say interest in the term 5 years will be, take the $12 we already have, multiply that by the 5 years altogether, and we get $60 earned in interest. Still, it doesn't fully answer the question. The question was, how much is in the account? We'll just take the principal amount of $300, tack on the interest, and that'll be our answer. So we can say total value in 5 years is principal $300 plus $60 earned in interest, totaling to $360 altogether. So The nice thing about simple interest is it's pretty quick to get to that formula, or excuse me, to that value. We didn't do any big formula other than just reason through here. We wanted 4% of the principal amount, so we just multiplied by 0.04 to get the interest. Then we just multiplied that by 5, the term length, tacked it onto the original principal. Well, any questions at all, folks, getting through this one? Okay, definitely a lot less intense than the insurance problem we were dealing with, I would assume, for a lot of people. Example 2 is just another kind of problem along similar lines. This one has kind of more involved context. It says, you lend a family member $8,000 to help them buy a reliable car. Maybe this is for a younger sibling, something like that. You're feeling really charitable. You can imagine this happening in real life. They agree to pay you back in 6 years with a simple interest rate of 2.5%. So assuming they're possibly making payments, that was the goal. But the further drama in the problem is this family member ended up losing their job, was not able to make a single payment in 6 years. So assuming this arrangement is still on the table, you loan them $8,000. We're only charging simple interest, feeling charitable again, at 2.5%. You want to figure out, well, how much are they going to have to pay you back once they get back on their feet? It's year 6, and we are going to update the balance. First, let's start breaking down the problem. We need a principal amount. We're going to need an APR. And we're also going to know the term length that's implied in this problem. It talked about family member ended up losing their job, was not able to make a single payment in 6 years. And how much do they now owe you? That assumes 6 years later. So that would be the term length of 6 years in this problem. Anyone spot what the other two values would be in this problem?
Your principal is going to be 8,000.
Yeah, absolutely. So this is the original amount we lent out. It feels different because example 1, we were making a deposit, but these problems work in both ways. Whether you're investing, this is a kind of investment in a certain sense. You're lending out this money with the hopes of getting it paid back, but that's not what happened in this one. So now it's turning into a kind of investment. How about for the APR? What number would you all put down for right here?
2.5%.
Yeah, absolutely. So the APR is this interest rate, 2.5%. So we'll convert that to a decimal number of 0.025. And pretty much that's all the moving parts in this problem. We can break it up into 3 steps as before, or maybe combine the first 2 steps, find the interest in 1 year and just immediately multiply it by the term length of 6 years. I'll leave that up to you as a judgment call. But really, once we have these 3 figures, it's going to be just like the last example. Any questions at all, folks, with the organizational step? Oh, sorry, I missed the comments in chat. That's absolutely right, Echo. The interest, and Amy, the interest will be 2.5%. So that'll be the number that we'll use in that dual step up here. Okay, well, let's put this together. If we follow the kind of the same pattern of attack as before, again, if you like, you can just combine these 2 steps, but it doesn't hurt to break it down a little bit more. Interest in 1 year will be take the principal and then multiply it by the APR written in as a decimal. So now we're taking $8,000, multiplying it by 0.025, and altogether that's going to come out as, let me get rid of that window, 8,000, 0.025, $200 is the amount of interest unfortunately earned, because that means we weren't paid back on this family loan, but that's how much in just 1 year. But then some years went by, 6 years, maybe the siblings are estranged, something went on, or maybe the sibling is under some really hard times. We have 6 years of simple interest racking up, so we'll take that and just multiply it by 6. So interest in 6 years, take the $200, multiply it by the term length of 6 years, gets us to $1,200. But that's just the extra amount this person owes. The total value, or the total amount they now owe, let's phrase it in those terms to match the context. Total amount owed to you would then be the principal, 8,000, add on the simple interest of $1,200. And so now it's climbed up to $9,200. Not too terribly extreme. The interest rate was low, but the bigger deal also is, even though it was 6 years, it was simple interest. So even after the first $200 was added on in the first year, no interest at 2.5% APR was ever paid on the first 200 or the next subsequent ones as well. So that's the total amount. Well, simple interest is kind of a nice landscape. And again, there are arrangements that happen that go along these lines. But any questions at all, folks, getting through either computation? Okay, let's suppose something went differently. You didn't lend the family member $8,000, so they had to go get a personal loan, maybe at, say, Chase, Wells Fargo, or maybe a credit union like Westmark, Mountain America, so on. There's millions of different banks and credit unions that might give you that loan if you have collateral for it, but they are not going to charge simple interest. So that's what this example down below is all about, the so-called comparison example. Here we're going to compare what's going to change when we go to the new landscape of compound interest. It's the same setup as before. Well, we're imagining this is going on with the bank, but let's say you decided to change to compound interest. Maybe you just didn't feel happy about that family member. They still lent them $8,000, so that's still going to be the principal amount. To buy a reliable used car, they agreed to pay back in 6 years. So we still have that as a term length. And if they were making regular payments, that's going to be what the next section is all about. What should those regular payments even be at that interest rate? But we'll get there in the very next section, Unit 4D. Here first, let's go and just continue with the organization. APR is at 0.025, that 2.5% as a decimal. And term length, we just use Y for years, is going to be 6. But this time, we're going to compound every year, which means after the first $200 is tacked on, the amount owed on the loan is going to be $8,200, but that becomes the new principal for which the interest rate of 2.5% is going to be subject to. So we'll have interest on the $200 of interest, and we'll compare what is going to be the new value if not a single payment was made in those 6 years. How much are they going to have to owe you? So that's the setup. We're really just transitioning between the landscape of simple interest now into compound interest. And I scrolled too far too soon. Sorry about that. The first row is going to be similar to what we already calculated. Let's build a table that goes like this. In the first column, I'll say amount or principal. Maybe principal is a bad word. Let's go with, say, amount in year. And below I'll just say 1, so that we're talking about the amount in year 1 in this row. Then on the next column, we'll say interest. Or hang on, sorry, I'm not thinking too great about my table. I want to just say in year for the first column. Sorry if you're working in pen today. And the second column, I want to say total amount. So if I place 1 here, then we're looking into just year 1. And the formula is pretty similar. We'll just take our 8,000, multiply it by the APR, 0.025, and actually let me backtrack. Sorry for the misstep on that. I'm looking into the total amount, so I want to do in one step this part right here, the 8,000 plus the 8,000 again, multiplied by the 0.025. Okay, sorry for the missteps getting started on this one. For the total amount, this part I accidentally wrote first is the interest. It's going to look better if I put that principal first. And we already know what this is going to come out as. The interest part is $200. We're adding to the original principal, so we're getting $8,200 altogether after the first year has gone by. Let's double check that in the calculator just to make sure the numbers are working as intended. Take the principal 8,000, but then 1 year has gone by at an APR of 2.5%. So take 8,000 again, multiply it by 0.025, and we get the 8,200 that we're expecting. That was a hard table to come up with from scratch. Sorry for the missteps getting started on it. Does that make sense to folks on getting that first row there? Okay, so 1 year's gone by. The family member, I'm imagining a sibling when I think that, has not paid anything on this loan. And now we're going to look into what if 2 years have gone by. So now we're in year 2. The APR hasn't changed, but what has changed is the total amount owed. The principal is still 8,000, but we're charging interest at 2.5% on 8,200 now. So the formula is going to become take the 8,200 plus 8,200 again times 0.025, and that will give us the new amount. I wanted that to be green just to show where that ties in. So this is going to be the total value that we now are owed to back to us in year 2. If it was simple interest, it would just be $8,400 altogether. But because we're charging interest on the $200, it's going to change on us. We'll go 8,200 plus 8,200 again times 0.025. We get $8,405. So the $5 is the extra amount, the 2.5% on just the $200. So $8,405 altogether on this row. And that takes care of this computation. Does that make sense to folks on this very first compounding that happened in year 2? Okay, the way we're writing it down is mainly to just tie back how row 1 works. We wrote it essentially the same way in row 2, just the new figure went into this position. But there's kind of a nice shorthand for writing these out. It's kind of clunky to write down 8,200 twice, but you could go like this. There's a greatest common factor here. 8,400 appears on the left side and the right side across addition. You could factor it out as a greatest common factor and rewrite this whole thing like this. 8,200 times, when we factor it out, it leaves a 1 in this position. We're using the distributive law in going in the reverse order now. Factoring that from here just leaves a 0.025. And we get the same exact figure. So this is just kind of a nicer, more compact way or shorthand for writing it. Let's start doing it this way in the upcoming formulas, just so that the notes don't look too convoluted. We're going to reuse this, but with $8,405 on our next row. So now in year 3, we're taking the $8,405 we have here, but reusing this format, 1 plus 0.025, multiply all those together, and here's what we're going to get. 8,405 times 1 plus 0.025, or you could just call that, add them together, a 1.025 and for the same result. And at this point, because we're dealing with money, we're going to have to round to the nearest cent. We're up to $8,615.13. So it's starting to rack up. The growth rate is accelerating in a certain sense, slowly at first, but if enough years will go by, this starts to grow exponentially in the literal sense. So we'll finish this off, get to year 6, but already we're $15 above what the simple interest landscape would have been. Simple interest would have just added $200, 1, 2, 3 times, to give us a total amount of $8,600. But if we're feeling less generous and we're saying we're going to lend that compounded annually, we're clawing back another $15.13 from this family member. Let's take a look into now year 4. 5 and 6 to see how it's going to land, where before we landed on 9,200, we're expecting a decent amount above that. So following the process, we'll take this amount here. We're going to charge 2.5% APR on that. So go 8,615, 1 plus 0.025, and that'll give us our next dollar amount. So here, we pretty much have the right structure. We just need to put in the amount. 8,615. Oh, and I forgot the 13 cents. That is important. Let me see if I can squeeze that in. 8,615.13. Every cent is important in banking and accounting, so we can't leave that off. And now we're up to $8,830.51. So it's taken us some time to get to row 5 and row 6. We're starting to use a shorthand already on the 3rd row just to streamline how we're putting this in the calculator, how we're writing it down. But actually, there's a even bigger shorthand to all of this so far. One thing we could have done is, if we want to just build out this table really, really fast, we can use the same structure, start with the original principal. That was the wrong key. Start with the original principal of 8,000. Where it is right now, there's an exponent of 1, and you get 8,200. But we're in year 2. All we have to do is raise that thing in the parenthesis to a power 2. That gets us $8,405. We want year 3. We take this part right here, raise it to power 3. Make sure you're using the original principal. And that's the shorthand to get the amount in year 3, rounded to the same cent. Likewise, for year 4, raise that to power 4. And notice there's a discrepancy. That's because we rounded this one. If we were using exactly what the bank would have done, this would have been to 50 cents. For this kind of problem, it's more of a comparison example, so we're not as worried on getting it accurate to the penny. But for the MyLab exercise, the ones down below, we will worry about the nearest penny. If we're off by 1 cent, MyLab complains, and it's really frustrating. So we'll be really careful as we compute going forward. But for a quick comparison example, we'll let that 1 penny slide. Let's use it on the last rows. We want to get row 5 and row 6 as fast as possible. Here's what it looks like. We take the principal of 8,000, take 1 plus the APR as a decimal, 0.025, but then we just raise it to the term length of 5 years if we're on row 5. So principal goes there, the interest rate goes there, and now to the nearest cent, we have $9,051.27. We are $51.27 above what the simple interest computation gave us. And finally, for year 6, notice that's the term length. It enters into the formula right here. We'll get the principal amount of 8,000. One plus the percentage, 0.025 now as a decimal, raised to an exponent 6, the term length. And here's what we'll get altogether. 2 power 6, rounded to the nearest penny, it's $9,277.55. Well, we did it, folks. That's the comparison of the simple interest, where we'd have only charged over the 6-year term $9,200. We're now charging this family member $77.55 extra if we were compounding annually. So this section is called the power of compounding. And here it is. The power of compounding in this context is $77.55, a decent chunk of change. Any questions whatsoever, folks, getting to this line right here? Okay, one thing that is definitely tricky about this section is we have to do this in a calculator quite a bit, where we'll have to do it in MyLab, we'll have to do it as a quiz problem, as well as in an exam setting. So now's a good time to start just practicing how does this really look in a calculator if we were to write it out. I use Desmos, which is just a fast classroom demonstration tool. But in this calculator, here's what I would punch in to get the same result. Start with the principal amount, and I should highlight that. Sorry for the omission there. Start with the principal amount, 8,000. So I'll punch that in the keypad in the normal way. We'll have a readout that looks about like this. It's a little bit bigger on the real calculator. Hit the times symbol, and just to remind myself what that looks like, you get a little star that comes out that indicates you've multiplied. And here's where we have to be really careful. This part right here has to be grouped as you see it with order of operations. So the next thing you need to select in the calculator is going to be the open parenthesis and the closed parenthesis. So we have to be really careful with how they all comes together. Hitting the open parenthesis will open a parenthesis as expected on the calculator. Then we can type this in, 1 plus 0.025. Probably at this point, you've kind of scrolled far on the calculator, and what you started typing already is not visible. But you can use the left arrow key, the right arrow key to see the whole thing. I just need to write this in a little bit smaller so I can actually fit it in. 1 plus 0.025. Be sure to close the parenthesis. And now the next thing we need to get is that exponent right there. Times 6 won't do the job whatsoever. We need to use the exponent key on our calculator. And that's this key right here, the up arrow key. So click on that there. Let me double check, make sure it looks the way I think it should. 8 to a power. Yeah, it looks about like this after you correctly hit that key. You get an up arrow that looks about like that. It's kind of higher up. I guess that's to indicate we're putting something in the exponent position. We're putting in the term length of 6 years, so just type 6. If it looks just about like that in your calculator, various calculators might look a little bit different. Casio models, different Texas Instrument models. But this is about what it should look like, and you should get that figure there. Well, any questions at all, folks, with those keystrokes? Okay, well, let's try the next formulas to see how this all comes together for the next problems. Those are the major calculator operations we would have to use. And if you have a different calculator, like a Casio or some other thing, don't hesitate to write an email about it or send a message through Canvas. I'll be happy to walk you through the instructions. Major thing is we have to learn it now so that it's less frustrating when we do it in my lab, less frustrating when we do it as a quiz. But most importantly, we have to do this in an exam setting with the calculator that you bring. So learning it now is going to make the exam go smooth. Well, the thing about this formula that we just used is that's pretty much the compound interest formula. The formula goes the amount in an account after, let me write it out this way, the amount in the account, that's this A right here, the amount accumulated after Y years is equal to a principal amount. Also press the time symbol there and just throw in the parenthesis. 1 plus APR raised to the power Y, which is the term length. And that's the formula that we used on both rows 5 and 6 above. So it's a pretty sensible formula. Really all it's doing is using the distributive law by factoring out an amount. Then if you're going to get higher and higher years, all you're really doing is repeatedly multiplying 1 plus the APR. And so that's why power start coming in on each subsequent year. So down below, here's our major format for the first big formula. So again, we'll say A is the amount accumulated, or the balance after Y years, where that's weird, that keeps moving around. Oh, I think the other one is the one I fixed. Y is the number of years, or the term length. P is going to be the starting principal, and A is going to be the annual percentage yield, or the annual percentage rate, rather, not the yield. So that's going to be our next big formula. We'll practice in a couple problems. And really, this formula is the major one. We're just going to change gears a little bit when we say, what if we compounded semi-annually, twice a year, or monthly, 12 times a year, and so on. But any questions so far, folks, with how the formula works, either in the problem above or written down there as a formula? Okay, let's see what's going on in this example down below. I have two pretty similar kind of looking examples to work through this formula. I don't know if I want to rush through it with the time we have, but let's look through the context to see how it all comes together, and then we'll revisit example 3 when we come back on Wednesday's class. So just getting started thinking about how this formula comes together, notice there are really 3 variables and one thing that we're going to compute. 4 variables total, but A is the value we're going to get when we essentially hit enter on the calculator. So example 3 says, you invest a recent tax refund of $4,000 into a mutual fund. That's a pretty big tax refund, but let's imagine you've got a $4,000 refund. Well, because that's being invested, that's going to be the starting principal in this problem. Got the wrong color here. So 4,000 is being invested into a mutual fund. The fund is expected to earn an average APR of 6% compounded annually. There's some risk there. We don't know if it's really going to be 6%, but assuming it hits that average and you make no withdrawals whatsoever, no further deposits, we can use the formula above to determine what the accumulated balance will be after 10 years. So putting this all together, the principal amount is going to be that tax refund that we've sacrificed into a mutual fund, which will be invested, that's the first block P, at a hopeful interest rate APR, annual percentage rate of 6%. But recall, to use this in the formula correctly, it must be as a decimal. So we will write in as a 0.06. And that's a little warning that they put right here. It might not be a bad idea to really highlight that. The numbers are just not working out. That might be the only thing that was wrong in the calculator. The next thing we need to know is the term length. This is going to be for 10 years. We're not touching this. So y equals 10 years in this problem. So put that all together in the calculator. We'll have a value out. Again, I don't want to rush through it since these are important problems. And really, there's two skills we're learning here: how the formula works, how to substitute information into the formula. But the equally important skill is how to use the calculator at the same time. If you just punch it in, you might already have a value, but we'll revisit this when we come back next class. And by the way, if you're curious what's going on with the mutual fund, the definition is below. This is a fund managed by a large investment company. What they do is they take your money, they pull it with money from lots of other investors, and they invest into a diversified blend of things along the lines of stocks in the stock market, bonds, other securities. And so there's a little bit of protection there. If you invest $6,000 into one stock and it goes belly up, you're potentially out all the money. But mutual funds show you the track record of how they performed over the years and the decades. And if one sector of the economy goes down, the mutual fund is diversified. You might take a hit, but you're not going to lose all your money unless the entire economy collapses. So we worry about that, but we hope it never happens. So again, we'll come back to this one next time, compare it with a Platinum Savings Wells Fargo account. This is real information on the problem down below to see how interest builds when we compound. Well, any last questions or comments, folks, before we call tonight, just a few minutes early today? Okay, and by the way, if you did practice this with your calculator already, good on you. This is what it should come out as, just for quick reference. This should come out to $71,163.39. If you're getting a different value, don't hesitate to ask, and we'll be, again, looking at how this goes into the calculator very carefully on each one of the problems, so we shore up that skill in time for the exam. But have a great night, folks. We'll be back to this example here on Wednesday.